Following those same 3 steps, we're going to graph the next one. We'll start with the line of symmetry. We'll find the vertex, and then we'll solve for the roots, x-intercepts, or the zeros. So using this one, let's take a minute. Make sure we can identify the A, the B, and the C. In this case, A is 1, B is positive 8, C is 15. Remember, C stands for the y-intercept. Some things that I know, we will start with the LOS, the fold line, the line of symmetry. X equals the opposite of B divided by 2A. X equals the opposite of B divided by 2A. Negative 8 divided by 2, negative 4 for x. So starting here, 1, 2, 1, 2, 3, 4, doing my best to make a nice dashed line. X equals negative 4. That is my line of symmetry. Great. Now, trying to keep with the same colors, we will work with our vertex. Will this vertex be a minimum or a maximum? Well, A is positive, so that means we will have a positive smiling parabola. It will have a minimum. Now we will use the LOS of x equals negative 4. Put that into your equation. Y equals negative 4 squared plus 8 times negative 4 plus 15. Be careful with squaring a negative. Make sure your calculator does not lie and tell you negative 16 when it is positive 16. When I am done doing that, I get negative 1. Therefore, my vertex is the ordered pair negative 4, negative 1. Negative 4 comes from the line of symmetry. So negative 4, negative 1, right there is my vertex. Negative 4, negative 1. Hard to write on the graph. It is a minimum. So I know it's okay to write at the bottom because it's going to be smiling. Our next step is we're going to find the roots, which are known as the x-intercepts and sometimes called the zeros. Well, because A is 1, I need to find two numbers that add to 8 but multiply to 15 at the same time. That would be a plus 3 and plus 5. Add to 8, multiply to 15, so x plus 3 times x plus 5. And we're going to set them equal to 0. My first x-intercept is negative 3, right there where x equals negative 3. Then I set the next one equal to 0. X equals negative 5. We're at negative 4, so negative 5. I'm just going to grab a darker pen so you can see it all right. And that is the basic shape of our parabola. This point is 1 to the right of the line of symmetry. That point is 1 to the left of the line of symmetry. Remember, our y-intercept is 15, but on this graph it would be way up there. It does not fit. Okay, we're going to turn the page and go to the next graph. Okay, I had to turn the page. So starting where we were, We know our A, our B, our C. I'm making a mental note that it will be a positive parabola, smiling because A is 1. We're going to start with the line of symmetry, where x equals the opposite of B divided by 2A. Opposite of 4 divided by 2 times 1. That would get me negative 2, where x equals negative 2. So I'll go to where x is negative 2, draw in my line of symmetry. Very nice. From there, we go to our vertex. It's positive, so we're going to have a minimum. And we need to use the line of symmetry where x is negative 2. I'll put that into my equation. Negative 2 squared plus 4 times negative 2 plus 3. When I'm done doing the math, I get negative 1. Therefore, my vertex is negative 2, negative 1. Negative 2 came from the line of symmetry. Negative 1 came for substituting there. So we have a vertex of negative 2, negative 1. It is a minimum. Now we're going to go for the roots, x-intercepts, known as the zeros. Well, again, A is 1, so I need numbers that add to 4, but multiply to 3. Well, a positive 1 and a positive 3, add to 4, multiply to 3. And now we will solve. There is negative 1 is one root right here. And then I solve the second one. And our second root is x equals negative 3. Well, notice they are each 1 away from the line of symmetry, so if I could fold, that'd be great. On this graph, though, we're going to add in the y-intercept because it fits. The other numbers were bigger than our graph. This is the y-intercept, so 1, 2, 3. Right there is the ordered pair 0, 3, because that is the y-intercept. That is 2 units to the right of my line of symmetry, so I know 1, 2 units to the left, I will have another point. This time when we go to graph, we can even be more accurate because we have 5 points on our parabola. I did not do a good job connecting my points. If this is negative 2, 2 more to the left, I would have the ordered pair of negative 4, 3. That's a lot of information on one graph. What I would like you to do is pause the video, do exactly everything we just did right here for the next one, and then you may stop. Pause the video, do the next one. If you want to have a challenge, go to the next one at the bottom also. Pause the video, please.